We are back with mathematics students. Today we'll be looking at the perfect squares. That's our discussion. This time around, a continuation of what we've been doing in the past. That's in the past lessons. Right. So here, what we're going to do first is an issue of discussing issues concerning the perfect squares, where we need to know what type of expressions are known as perfect squares. Right. Like say for example, in the normal circumstances, we have some numbers which are defined as perfect squares. And some numbers are not perfect squares. For example, look at this. If I multiply 6 by 7, what I get here is 42. And then I may also multiply other two numbers like talk over 7 multiplied by 7. The answer I get here is 49. The third example, for more understanding, let me have 10 multiplied by 10. You get what is what? 100. Right. Now, if we can compare the three numbers here by the factors of each, like here I've got the number 42, which is as a result of the product of two different numbers, which is 6 and 7. And here's another number, which is 49, which is just a result of the product of two identical numbers, 7 and 7. And here I have also 100, which is the product of identical numbers, which is 10 and 10. So we found that these three numbers, they differ by the factors in terms of their product. Right. Two numbers which have got the identical factors, such as 49 and 100. These two numbers are good examples of what we call them as perfect squares. Right. Which simply means, in this case, a perfect square by numbers is just a number which amongst them have got two identical factors. There can be several factors, but amongst do we have some identical factors? Right. Those numbers are defined as what? Perfect squares. So the application of which also goes into the what? Quadratic expressions. Right. For example, as I introduced the 42, 49, and 100, I may also have two expressions here to be multiplied which are identical. Like I say 7 times 7, 49. I may also have a good example, we talk of like say 3x plus 2, and then I have got here maybe x, we also talk of the 3x plus 2. If you look at this bracket, that bracket are the same. It's just like having 7 times 7 or 10 multiplied by 10. So now, students, can you try to expand the two expressions and see what we get? But each time we do this, let's be reminded that we are looking at the factors of an expression. As here we're discussing about factors of a number. So let's see what we have here. So when I'm expanding by multiplication, this by that, it'll be like 3x, top of 4 terms in the first bracket, should multiply the terms in the next bracket. So here it'll be like this 3x has to multiply by 3x, this one, plus a 2, that one. And then now we take the positive 2, this one has to also multiply by all the terms in the next bracket. Where we have got 3x plus 2. Think like that. Let's see what we get. So here it will be 3x multiplied to 3x. The answer we get there is 9x squared. And then let's try to multiply 3x by 2. What we get there, usually we get 6x. So here I've done the expansion, because expansion simply means just remove the brackets. Now go to the next category of the expression, where we're going to 12 outside the bracket, that must be multiplied by the terms inside. So here we get that is 6x plus 1 plus a 2. Right. By simple mathematics in algebra form 1, we can still more simplify this one by identifying the like terms. So we find that this expression has got 6x and 6x, which are like terms. We can obtain one term from the two. So here we have got the resultant expression as the 9x squared plus 12x plus 2. So now if you look at this one here, you'll be able to deduce that this one is coming from the multiplication of 3x plus 2 and then by 3x plus 2. This is giving us 9x squared plus 12x plus 2. Just the same as somebody gets this number here, 10 multiplied by 10 give us 100. So if we say 100 is a perfect square, coming from multiplication of two identical factors, then we're also going to say the same, that in quadratic expression, we have got some expressions which are also the perfect squares. Like here, 9x squared plus 12x plus 2 is coming from the factors which are 3x plus 2 and 3x plus 2. Right. Now, the question now we have here will be like, now, suppose they ask you to show, since we have got different types of expressions, how can we show that the expression we have at large is the perfect square? So let's have an example here where we need us to show that the particular expression is a perfect square. Right. Show that the following expressions are perfect squares. Right. A, we are given x squared minus 80x plus 16. Secondly, we have got 9x squared plus 12x plus 4. Right. So in your case, as a student, I don't think you can have some kind of hiccups when somebody asks you to show that a particular expression is a perfect square. I think you just be able to get and try to analyze the discussion here to say if one would need to show that the expression is a perfect square, it's just by the, like what we have did by the numbers, to say that you just have to find the factors of each. If the factors are identical, then what do? You conclude that the product expression is a perfect square. Like, so in this case, we need just have to calculate the two expressions and check what we're going to obtain. So I'll begin by example 1 here, right? We need to show that x squared minus 8x plus 16 is a perfect square. So the method we're going to use is only by factorization. So let's take our step through. X squared minus 8x plus 16. So the method remains the same we discussed previously. We have to consider the quadratic term multiplied by the constant term. This one gives us 16x squared. Then now have to look for the factors of 16x squared. The factors of which should be 2. That's the condition. That when you add, they have to give you negative 8x, a term in the middle of that quadratic expression. So the factors of negative 16, that when you multiply, can give you positive 16x squared, and when you add, you can get negative 8x, that's negative 4x, and the negative 4x. You try to multiply by this by that, you get this, you add this by that, you get negative x. So as usual, you're going to substitute these two factors for negative 8x and come up with an expression which has got 4 terms this time around, which is x squared minus 4x, then minus 4x. So when I write this, that's good as just writing 8x, because you simplify this just like that. Right, then plus 16. Then as usual, grouping. You go for this one and that one. You do the same. Identify the common factor for in each group. So for this and this, your common factor is x, and you divide x into x squared, you get x. X into negative 4x, you get negative 4. And then go for this other group. A common factor there, give these results, it will be negative 4. Negative 4 into negative 4x, you still get x. and negative 4 into positive 16, you get negative 4. Right. Then now, what do we do from this step? What we're going to do here now is the same story we said. That's identify a common factor again, but now in this case it will be in the form of the expression as such. So as you can see that here there's a bracket x minus 4, the same as x minus 4. So that one is also regarded as your common factor, which has to be divided here and there. And this is the result that we get. When this one divides here, we have got x, and this one dividing there, the answer is negative 4. So you see what we have here. We have got x minus 4 and x minus 4 as the factors of x squared minus 8x plus 16. So here is the good, at least a notification to tell us this expression is the perfect square. I think we have find different factors here by maybe size. In another bracket there's a positive, in another one is negative. That does not tell us that is the perfect square. But I'm going to have these ones as the identical factors. So in mathematics, we would prefer always not to utilize the terms, alike terms as such, but we just write in the short form and say x minus 4 multiplied by x minus 4. That's just as good as writing one expression, x minus 4, and then you write a power 2 there. And we find that there are 2 terms. Right, so by that, we use that say x squared minus x minus 8x plus 6 is a perfect square. So we conclude, let's say, therefore, x squared minus 8x plus 16 is a perfect square. Right. So this is the way we are able to show that the particular expression is a perfect square. Right. So here I have got another example, which is example B. But for this one, I won't solve it. I will leave it to you to try it. But the same mechanism which I've done here. Because if I do this one, it will be just like a repetition. So take this one as your exercise to write. So make sure that you follow the steps of the factorization we did that time and come and check what factors are there supposed to be multiplied, and you deduce out of it that this one is a perfect square. Right. Today we also stop here. In the next meeting, we'll be now applying this mechanism now into solving quadratic equations by completing of the square. Which means first we are there possible to discuss some of the expressions which are not perfect square. We'll try to make them as perfect square. Then now we jump into the solving quadratic equation by using the perfect square. Thank you very much for listening. We'll meet again next time. Thank you.